Welcome back. So when we last left off, we were talking about habitat loss, right? So I guess I wanted to say to you that it's not all so bad. Like, I mean, some of the ecosystems that we're looking at here are actually the disturbances are actually reversible. Unfortunately, others aren't. But here, let's take a look at one that is reversible. Um, Agriculture areas. Any abandoned agriculture area is able to transition back to forest through the process of ecological succession. So that's good news, right? We can see if you go over New England today and you look down, you can see forests covering hills and valleys and so forth. But it used to be that New England was extremely highly farmed. And so it took about 200 years or so, but the intensive agricultural practices that were happening back in the day, well, it's now forest, and that's a good thing. Um, of course, you know, there's a long history of settlement and abandonment, and so that's why we have information like this. If you take a look here at this particular reversible disturbance, this is Mount St. Helens, and this, this is probably before you were born. I don't know, so maybe not true for all of you, but in 1980, and I remember this, in 1980, Mount St. Helens erupted, and it was enormous, and the kind of dust, ash from Mount St. Helens was made it all the way to Maryland, where I was living at the time, where I was going to school at the time. So this explosion literally wiped out the forests that were around. There's the before the explosion, and there's after the explosion. There's nothing. It's a barren wasteland, just covered in ash. But if we look around, just a few years back, what we see are that trees are growing back, shrubs are definitely there. We've got all this new life forming at the foot of this volcano that's still active. So it's possible that this could happen again, but it'll probably recover again too. Some disturbances are irreversible, and here's the thing, and maybe this can change with technology, but it's very, very unlikely that once a species goes extinct, it's gone. There's no way that we can reverse this. Some organisms that we've lost are the Tasmanian wolf, and we've lost the Chinese river dolphin, these cool pink dolphins that lived in the rivers in China. They're gone, so irreversible. Even if we could bring back something that was really cool and we thought was worth bringing back, technology can only take us so far. So, and even if we brought it back, it wouldn't exist at the genetic biodiversity that it did in the past. So we've got some major problems here. And I hope you understand how important it is to continue to lose the biodiversity. We don't want to lose the blue whale. We don't want to lose those species. Okay, so that's how humans have caused disturbances, and we've changed ecosystems by just physically being here. But there's other ways that human activities can and have damaged the environment. The next one that we're going to talk about is introduction of non-native species, and how non-native species can, in fact, affect the native species. So the word that we're going to talk about is exotic species. The word is exotic, and any species that is exotic is one that's been introduced from a faraway location. So the monk parakeet that you see right here was brought into the United States as pets, but some people were tired of the pets. It was screeching, it was loud, they didn't like it in their house, and so they just thought they would be really nice and just let it go into the wild. And so they escaped and they survived and they bred. And what we see in this picture below of this beautiful green parakeet is how much of a nuisance it's becoming in the cities. They build these huge nests on utility poles, and it causes the electricity to go out, and it's very damaging to us. It really can affect us. So that's exotic species. That's any species that's been introduced where it's not from. But a subset of this is called invasive species. And invasive species are any exotic species that causes harm. So what you've got here with the monk parakeet is harm being caused, and specifically in this case, harm being caused to us, right? So that's not good. There's lots of examples of invasive species, and I'll step you through a few more of them besides the monk parakeet and how they affect the ecosystem, but also affect us as humans. So invasive species can be introduced intentionally, or they can be introduced unintentionally. And we'll talk about that a little bit and why, in my examples that are coming up, that might happen, why we might intentionally release them. I think that the monk parakeet would be classified as unintentionally, even though people were releasing it. It's more of an unintentional release because it wasn't a planned thing. Believe it or not, we have had planned releases of invasive species. So the characteristics, though, of introduced species, exotic species, is that they have no predators. They have no pathogens in the new habitat. And so what happens is that native plants and animals might not have a defense against the invading toxic species. So this is happening all over the world. It's happening right here in your own backyard. And I'll tell you about that as one of my examples as we get on. But whether or not non-native species are introduced accidentally or intentionally, they often cause harm. And when they cause harm, that's when they're invasive. Invasive species can just multiply, just reproduce unchecked, unchecked by predation, unchecked by competitors, and they do irreversibly alter the ecosystem. So what can we do about it? Well, regulation is a big deal. Like maybe you really like this plant, but if it's known to be invasive, maybe you shouldn't be planting it. And so maybe some government regulation might be involved. Either that, or if you don't want the government regulating this, then maybe you have to learn every single invasive plant and the pros and cons of each one. Or maybe you could rely on other people to help you with that, one way or the other. Kind of being vigilant against that is also a good way to protect against the disruptive impacts of invasive species. So here's a few examples of invasive species. The first one is the brown tree snake. This was introduced on the island of Guam accidentally, right? And it was eradicated most of the native bird species because these bird species had never had a snake predator before. They didn't have any defense mechanisms against it, and so the birds they're being eaten. Their eggs are being eaten. The next one is this beautiful flower. I mean, that's really pretty, right? It's called purple loosestrife, and it was introduced in the United States as a garden plant. Unfortunately, purple loosestrife invades wetlands, and it grows faster than the native grasses and sedges and flowering plants in every single state except for Florida. So if you see purple loosestrife growing out in the wild, understand that it is outcompeting our native grasses. And of course, the reason that's such a big deal is the food chain, right? Because the food chain, if the animals are used to eating the native plants and the native plants go extinct, then the animals are going to go extinct. The third one on this list is the zebra mussel, and this was introduced accidentally to the Great Lakes. And if you take a look at this, what this person is holding is a pipe, like a water pipe that's for to let the water flow back into the Great Lakes, or to pull water out of the Great Lakes to take to the cities and towns and so forth. So these are tiny little mussels, and they clog up the pipes. And this is a huge, huge problem. in the Great Lakes area. It's damaging industrial facilities. It's taking resources away from small fish, so those fish are going extinct. And it is because of that, the larger fish, the fish that you might want to fish for if you ever go up to Lake Michigan, they're actually decreasing as well, all because of this little zebra mussel. Locally, we have things like bush honeysuckle that are growing in the woods. If you look out in the springtime, the forests are just starting to green up. The very first plant that's starting to green up is the bush honeysuckle. And it was brought to the United States from Japan as a garden plant, but it has literally taken over every forest across the United States. And again, repercussions are huge. It's causing a decrease in biodiversity because it is so very effective at reproducing and it doesn't have anything that eats it. So, problems. Accidental introduction. Unfortunately, sometimes we introduce things very deliberately and then find out, oopsie, that was probably a bad thing. So what we have here is that in Australia, they introduced this frog, actually toad, sorry, it's called the cane toad, and they did it to control agricultural pests because cane toads eat these insects, and they thought, oh, well, we've got all these insects, let's just introduce this toad and it'll kill all the insects. And yeah, no, it's a really huge nightmare. Instead of just eating the insects, it's actually like doing things like killing indigenous snakes, killing lizards and birds, and even crocodiles. These cane toads are a huge problem for Australia, and their population has literally just gotten out of control. So this is an illustration of what happens when you deliberately introduce non-native species to control pests. Maybe we could have been a better solution. I mean, I say maybe, but definitely, and I don't know what that would have been. But now there's like billions and billions of dollars that are spent every year trying to combat these invasive species. And the best way to do this is early detection and rapid response. And we don't have any of those things happening in the United States. All right, so invasive species. That's one way human activities can damage the environment. Here's another. When we burn fossil fuel, it releases all kinds of things into the atmosphere that mix with water vapor. And in the specific case that we're talking about right now with burning fossil fuels is that some of those particles that are found in fossil fuels, like in coal specifically, will combine with water in the atmosphere and cause acids. So the two kinds of the two main problems here for the acid rain that we're talking about, or acid precipitation, I'm going to use those terms interchangeably, are sulfur dioxide, that's SO2, and nitrogen dioxide, which is NO2. And those are just kind of byproduct things that are found in fossil fuels. So sulfur dioxide, when it mixes with water, forms something called sulfuric acid. And sulfuric acid, H2SO4, sulfuric acid is an extremely acidic acid. So there's that. Nitric acid, HNO3 is nitric acid. Those both fall to the earth as acid rain. We see acid precipitation because it doesn't just have to be rain. So let's take a look at our problem and its cause. The problem is that acid precipitation kills plants, kills aquatic animals directly. They literally directly kill the animals because they're too acidic. But they also act indirectly on these organisms because they change the soil and water chemistry to be like literally non-livable. Again, the cause is the release of sulfur dioxide and nitrogen dioxide, causing our acids. And the real strategy for the solution here is to decrease the amount of fossil fuels that we burn in the form of coal. You've heard about clean coal. Well, what clean coal is an attempt to decrease the amount of sulfur dioxide and nitrogen dioxide emissions. But there's no real thing. It's not really a thing. It works okay, but it doesn't work 100%. And we have some pretty bad side effects. If you think about where the vast majority of coal plants are in the United States, we're talking about this region right over here. I mean, it's the Midwest, going into the East a little bit. But what's important to remember is that any form of precipitation that's happening here, where the coal is being burnt, isn't actually, for the most part, landing where it's burnt. It flows across the United States towards the east. And this can happen as rain or fog or sleet or snow. This water in the atmosphere can be 10 times more acidic than a regular clean rain. So clean rain, you're talking it has a pH of about 5.3 or so, and this is at 4.3. We're getting some really bad. But of course, plants and animals are happy up here and like really, really unhappy and dying over here. Let's take a look at what contact with acidic water does to trees. It kills them. I mean, you can see these trees are dead. And the main culprit here is exposure to acid rain or acid fog or whatever. One interesting thing that I think about when I think about acid fog is we always think about London as being really foggy. Like that's the thing that we think about. London is foggy. But the truth is that a lot of the fog in London was due to the burning of coal, and it was completely unregulated. When it became more regulated, the fog of London disappeared quite a bit. Not completely gone, but interesting to think about how human behavior can do something like that we think of as so iconic, like London fog. So direct contact directly kills living tissues. Indirect contact can also affect them by leaching essential ions from the soil, which of course prevents the ions from being accessed by the plants, right? It takes it out of the soil. It can wash ions into lakes and streams, decreasing or increasing the acidity amount, which is decreasing the number, just so you know, of lakes and streams. And some of those ions that were great for the plants on land are actually toxic to the animals that are living in the lakes. So good to know that acid rain is a solvable problem, right? All we have to do is stop burning fossil fuel, right? Yeah, that would take some definite concerted effort. I think we can do it though. All right, so the next one is that humans are damaging our environment by releasing greenhouse gases into the atmosphere. And so we know that the average temperature of the Earth has increased very fast over the last 50 years. And this fast increase in temperature is definitely affecting us. The cause is burning of fossil fuels again. It's also, though, back to what we were talking about earlier, clearing the land of trees and cultivating crops. One of the big things that we're releasing here when we talk about climate change, about global warming, is the release of carbon dioxide. And of course, you know that the more trees there are, the more carbon dioxide is removed from the atmosphere, and yet we're cutting down trees. So this can be a big problem. Solutions include decrease greenhouse gases from fossil fuels and plant more trees. Let's take a closer look, though, at this, what happens when we have too many greenhouse gases in our atmosphere. So let's just, before we get started on this, let's just list the greenhouse gases that I'm talking about. The first one is water vapor. I know you don't think of water vapor as being a greenhouse gas, but stand by as I talk about what greenhouse gases do, and then you'll understand why water vapor is actually a greenhouse gas. Carbon dioxide This is something that is definitely released from fossil fuels. Methane also released from fossil fuels, released from cows as they fart, also released from swamps as they, like in the tundra as they defrost. There's nitrous oxide, which is not the same, by the way. This is N2O as nitrogen dioxide that we talked about earlier. Ozone is a greenhouse gas. And so are things called CFCs. Now, CFCs are mainly man-made. They're used in industry for lots of things like insulation and semiconductors, and very interestingly, processing of aluminum. So all the aluminum cans that we use, we're putting CFCs into the atmosphere. So, okay, so there's our list of greenhouse gases. And again, let's just talk about what the greenhouse effect is, and then we'll talk about, again, what we're doing to contribute to this global warming greenhouse effect thing. So let me start out by saying that the greenhouse effect is a good thing. I know, I just was saying that maybe it's not a good thing, but you have to understand that if we didn't have the greenhouse effect, then the Earth would not be nearly as warm as it is, and uniformly warm as it is. So one thing that we know is that when the sun's rays hit the Earth and warm up the land, they bounce back off that land and they radiate back out into space. But it's actually the greenhouse effect that traps some of that heat in the close to the Earth, and that's a good thing because the sun can warm up the planet, but if it just radiates right back out into the atmosphere, it would be like living on the moon. It'd be really, really cold. Luckily, we have these greenhouse gases like water and carbon dioxide and methane and so forth that help trap that heat. So that heat is reflected back down toward the atmosphere, and it helps keep our air nice and warm. Some of it does escape, sure, but that's the basics here. So greenhouse effect, good. But what happens when you have too much of a good thing, right? If you have too much carbon dioxide in the atmosphere or too much methane in the atmosphere, what you end up getting is too much heat being trapped. The more greenhouse gases, the more heat that's trapped. You might think about, if you've ever taken a planetary science class, you might think about the planet Venus. Venus is farther away from the sun than Mars is, than Earth is, or than Mercury is. I'm sorry, I'm getting all sorry about that. Yeah. It's farther away from the sun than Mercury is. Mercury is like right up against the sun, but Venus is hotter than Mercury because Venus has more carbon dioxide than Mercury has. So that applies to us. If we continue to increase our carbon dioxide, we are going to have much, much less ability to regulate a temperature in a zone that we like, in a range that we like. So here's an example of some of the impacts of global warming. What you see here is an ice cap back from 1979. This is at the North Pole. And then you have the same exact ice cap in 2016. And it's much less than half of the ice that was once there is now there. And just to point it out, this is the ice cap right here, right? This is the ice cap. This is Greenland. Here we're talking about like the Canadian islands up there. We've got some Russia and so forth. There's our ice cap. And if you look at it now, and no, this is not an example of summer versus winter. This is an actual compared at the same exact time of year. It's shrunk just tremendously. We also see biological systems showing effects of climate change. Trees and flowers are blooming way earlier than they used to. Birds are arriving at their summer ranges earlier. Birds and butterflies are going northward where they weren't before. And of course, the Arctic ice is thinning and melting. So So all kind of fine. Like, okay, so we have some birds farther north, whatever. So, but there's some bad stuff too that's coming north that we don't want coming north, like infectious diseases. The range of insects going north is actually causing the diseases that they carry to go north as well. So that is a bad thing. Um, well, global warming is very difficult to challenge because it's so large, and unfortunately, so many people just don't think it's caused by humans. So how do you fight this? You as an individual, maybe you reduce your fossil fuel consumption, or maybe you as an individual use the power that you have in our democracy to help our democracy decide that this is what needs doing to help the entire country reduce its fossil fuel consumption. Reduce deforestation and replant forests. Maybe there's things you as an individual can do, but there's also things, in your backyard or whatever, but maybe there's things that you could do on a bigger scale by getting involved and getting out there and helping people realize, helping your elected officials realize that deforestation is impacting everybody, not just, the companies that are profiting from this. So you can buy a more energy efficient car or make your home more energy efficient. And there's things that you can do like put solar panels on your roof. Again, this is an expensive thing to do, but maybe it's more expensive to not do it, is kind of what I'm saying. Something to think about anyway. Um, the next thing that we're going to talk about is deforestation and how deforestation, especially of the rainforest, is causing a loss of species, and it's causing an increase in the release of carbon. So, yeah, if you cut down trees, you don't get as much greenhouse gases absorbed, and again, it's agriculture, but it's also logging, it's also mining, it's also oil well digging. So there's just all kinds of causes for why we do the deforestation that we do. Gold mine is a big thing. People are sifting the soil for gold in the tropical rainforests. So strategies for solutions, yeah, um, reduce that destruction. It gets complicated, especially if you think about, us up here in the United States saying, hey, y'all down there in South America better preserve your rainforests because we need them. Well, and they're over here saying, hey, we need this stuff for food. We need space for agriculture. And hey, who doesn't want to get some gold and oil and so forth? So, so we, it's a difficult situation. It's not so easy just to say, hey, stop deforestation. And yet we do know that there are some major impacts of deforestation on the world. Like we've already talked about how reducing biodiversity is a big deal. We've already talked about how increasing greenhouse gases is the big deal because there's no photosynthesis happening. So cutting down those trees accelerates climate change. Yeah, we need to do this. But like I said before, we can't just tell people what to do. We need cooperation, and we need lots of different strategies. So maybe what we need to do is identify and protect the most diverse areas. That's a big thing. Okay, maybe we could lose a little bit of this rainforest, but not this part. Addressing poverty. This is a huge deal. And maybe you think it's not our business to be helping people in South America with their poverty. But if there wasn't so much poverty in those countries, then maybe they wouldn't be cutting down their rainforests, their resources. Develop alternative sources of food and income. And here, we're not just talking about for the people, the local people. We're talking about for us as well. The food that we eat contributes to deforestation as well. For example, we really like coffee, and coffee is a big problem when it comes to deforestation. You can buy coffee that's responsibly grown or sustainably grown, shade grown, ones that are grown in the forest that can help reduce population growth. The fewer people we have to feed, the better we are. So help educate, help go through the demographic transition. Other countries, maybe help them go through that demographic transition faster, so that the population won't be growing as fast as it might have been if they go through the demographic transition slower. And of course, education. All of these things put together could help solve the future deforestation. We can also do things like planting trees. We can increase and shift our economic focus from wood to non-wood forest products. For example, a great alternative to wood products is bamboo or hemp or things along those lines. So maybe not using paper from wood so much. So we're on to one of our next to last topics, I suppose, and that is thinking about the ozone layer. And I'll come back on my next video and we'll finish up our conservation and biodiversity chat. See you in a minute.